Okay, hello everyone. Let us continue the second part of today's class. Okay, at the beginning, let us see the new announcements. Okay, the first new announcement is the slides of Chapter 2 has been updated. Version 2022-0421B. Hello everyone, I have uploaded the latest version of slides of Chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content Slides Chapter 2 Slides 2022-0421B.pdf. Best regards, Wei Zhen. Okay, the second new announcement is the handout of Chapter 2 has been updated. Version 2022-0421B. Hello everyone, I have uploaded the latest version of the handout of Chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, handouts. Chapter 2 handout 2022-0421B.pdf. Best regards, Wei Zhen. Okay, next let us continue the progress of part 1. Okay. Okay, please open the slides. Okay, and turn to page. Okay, let me see. Where did we? Okay. Okay, so in the last class, we have taught to page 34. Okay, so as per equation 2.2, okay, let us see equation 2.2 is the corresponding SINR for secondary user I and expected to satisfy the condition that is gamma is equal to this equation and is greater than or equal to secondary user I's required SINR threshold determined from quality of service QoS goals. Okay. And ALT reflects whether the interference condition of the primary user is satisfied according to the underlay dynamic spectrum access approach. Okay, namely, what is the meaning of namely? Okay, let us see the handout. Okay. Okay, page 35, problem 1. What is namely? Solution used when you want to give more detail or be more exact about something you have just said. Okay. So let us go back to the slides. Namely, IIT is equal to 0 if gamma ITS is greater than or equal to gamma I. Okay. where gamma ITS is given in equation 2.2. Okay, let us see. Okay, this is the equation 2.2, but here is the gamma IS. This symbol do not have the subscript T. Okay, so what is gamma ITS? Okay, it is the SINR of the ith secondary user at time instance T. Okay, if gamma ITS is greater than or equal to gamma I, then IIT is equal to 0. Otherwise, IIT is equal to 1. And LT is equal to 0 if gamma 0 TP. Okay, gamma 0 TP is given in equation 2.1. Okay, we can see that in equation 2.1, the signal to interference plus noise ratio SINR of the primary user, gamma 0 P, is expected to satisfy the following condition. That is, gamma 0 P is equal to this equation and is greater and is expected to satisfy which is greater than or equal to gamma 0. Gamma 0 is the primary user's required SINR threshold as determined from the underlay dynamic spectrum access configuration. Okay, so here gamma 0 TP, okay, is the SINR of the primary user at time instance T. Okay, so if gamma 0 TP is greater than or equal to gamma 0, LT is equal to 0. Otherwise, LT is equal to 1. The action of secondary user I is defined by AIT. Okay, that is, the action of secondary user I at time instance T, okay, is equal to this pair PITS. Okay, this is the power level of secondary user I at time instance T, and RITS is the channel coding rate of secondary user I at time instance T. By equation 2.7, okay, let us see equation 2.7. Okay, equation 2.7 shows the end-to-end distortion of secondary user I DI, which is a function of PS and RIS, okay, and can be written as this function. Okay, we define the cost function of secondary user I at time instance T as follows. Okay, small CIT is equal to capital C. Okay, if LT plus IIT is greater than 0. Okay, what does this condition mean? Okay, we can see that if the sum of IIT and LT is greater than 0, then at least one of them is equal to 1. So at least one of the SINR condition is broken. So at least one of the SINR is smaller than the threshold gamma I or gamma 0. Okay, CIT is equal to DIT. Okay, it is the end-to-end distortion of the ith secondary user at time instance T, which is a function of PITS and RITS otherwise. Okay, where capital C is an arbitrarily large constant, larger than the maximum possible value for DIT of PITS RITS, indicating a failure for a secondary transmission to meet the target SINR, or the violation of the dynamic spectrum access rule for the primary user. Okay, because the secondary user I or the secondary transmission failed to meet the target SINR, so it should has a greater cost than the second case. Okay, the second case is a success for a secondary transmission to meet the target SINR. Also, DIT of PITS RITS follows from equation 2.7. Okay, let us see equation 2.7 again. Okay, is this equation. With the system state, secondary actions and individual cost functions defined by equations 2.8 through 2.10. Okay, let us see equation 2.8 through 2.10. Okay, in equation 2.8, we defined IIT, and in equation 2.9, we defined LT, and in equation 2.10, we defined small CIT, which is the cost function of a secondary user I at time instance t. Okay, we are ready to approximate the decentralized strategy searching process by a group of standard single agent Q-learning. Okay, we have explained what is Q-learning. Okay, if you forget it, please review the handout of chapter 2. Okay, Q-learning processes. Please see Sutton and Bartle in 2011. Okay, Richard S. Sutton and Andrew G. Bartle has written a book, Reinforcement Learning, an Introduction, and which is published in 2011. Okay, this book is the Bible in the field of reinforcement learning. And Wang et al. In 2016. Okay, we can see that W. Wang, A. Kwasinski, D. Niato, and Zhu Han has written a paper, A Survey on Applications of Model-Free Strategy Learning in Cognitive Wireless Networks, okay, which is published in IEEE Communications Surveys Tutorials. Okay, this journal is of ranking 1 in the viewpoint of the impact factor among all the telecommunications journal, okay, which was published in 2016. Okay, I have put a hyperlink here. Okay, you can click this hyperlink, and your browser will automatically open the web page of this paper, and you can click this red button to download the PDF file of this paper. Okay, let us go back to the slides. Here, by approximation, we assume that the secondary users do not observe the joint secondary user actions and are unaware of their effect on state transitions. Namely, each secondary user treats the other secondary users as if they are part of the stationary environment. Let pi I of A given Si denote the probability of secondary user I selecting action small a which is in capital A. Okay, what is capital A? Okay, let us see a review this symbol. Okay, capital A is the set of system actions. Given the observed state Si, okay, where Si is the state of secondary user I. Okay. So Si is equal to a pair IL. Okay, what is IL? Also, we do not define symbols I and L in the previous slides, but I think you should be able to guess what are I and L. Okay, I and L are defined in equations 2.8 and 2.9 with the subscripts omitted. Okay, we consider that secondary user I repeatedly adjusts its strategy pi I in order to finally obtain an optimal strategy that minimizes the state value. That is, the expected sum of costs over time with a discounting factor. Okay, what is a discounting factor? Let us see the handout. Okay, page 38. Problem 1. What is a discounting factor? Solution. A discount factor is a weighting factor that helps convert future values into the present. Okay, let us go back to the slides. Okay, discounting factor beta I, where 0 is smaller than beta I and beta I is smaller than 1. Okay, V pi I of Si, okay, it is the expected sum of costs, okay, under the strategy pi I and the state Si, okay, where Si is the state of secondary user I, and it is equal to E pi, that is the expectation of this term with respect to pi, where pi denotes the strategy. Okay, and in the bracket, let us see. The first term is Ct plus 1. Okay, it is the cost function of at time instance t plus 1. And this is a function of Si and Ai, where Ai is the action of secondary user I, plus beta I, okay, beta I is the discounting factor, times V pi I of Si t plus 1. Okay, so we can see that here is a V pi I of Si, and here is V pi I of Si t plus 1. So it is a recursive definition, okay, of V pi I. And Si t plus 1 is the state of secondary user I at time instance t plus 1. Given SIT is equal to Si, that is, the state of secondary user I at time instance t is equal to Si, where this Si is equal to this Si. So the expected sum of costs V pi I is a function of Si. Okay. And given the SIT equaling to be equal to Si, we can find the expectation of this term. Okay, so according to Bellman's principle of optimality, okay, what is Bellman's principle of optimality? Let us see the handout. Okay. Okay, problem 2. What is Bellman's principle of optimality? Okay, solution. Before understanding the Bellman's principle of optimality, we need to introduce a dynamic decision problem. Okay, let the state at time t be xt. For a decision that begins at time 0, we take as given the initial state x0. At any time, the set of possible actions depends on the current state. We can write this as at, which is in gamma of x of xt. Okay. At is the action at time t, where the action At represents one or more control variables. Okay, and we can see that At belongs to a set, and this set is a function of xt. We also assume that the state changes from x to a new state t of xa, okay, where t means the transition. Okay, it means a transition from an old state x to a new state, old state x to a new state under action A. When action A is taken and that the current pay off. Okay, what is the meaning of payoff? Let us see problem 3. What is payoff? Solution: the result of a set of actions or an explanation at the end of something. Okay, let us go back to first payoff. Okay. From taking action A in state X is f of xa. Okay, that is payoff. Okay, we take the letter F to represent the payoff. Okay, you may ask a question: why do not we use the letter P to denote the payoff? Because if we use P of xa, usually P is denotes the probability. Okay, so we use F here, f of xa. Finally, we assume impatience. Okay, what is the meaning of impatience? Okay, let us see the problem 4. What is impatience? Solution: the feeling of wanting something to happen as soon as possible. Okay, let us go back to the first impatience. Okay, it is 25 minutes. Let us take a break.